This is Mr. Martin. This is a video for section 11.2 for Precalc Honors. We are discussing limits and how to calculate limits. So this is video 2 for section 11.2. We're going to start off by talking about a limit from calculus. So this is called a difference quotient. So notice here I have a quotient because it's a fraction, and in the numerator I have a difference, and that's what makes it a difference quotient. So we're given the function f of x is equal to 2x squared plus 1, and we want to find the limit of this difference quotient as h approaches 0. So the first thing that we're going to do is we're going to figure out what f of 2 plus h is and what f of 2 is, not necessarily in that order. So let's figure out what f of 2 is. So f of 2, we're just substituting in 2 here. So I have 2 times 2 squared plus 1. So that's 4 times 2 is 8 plus 1 is 9. And we need to figure out what f of 2 plus h is. F of 2 plus h. So now everywhere that there's an x in here, I'm going to substitute in 2 plus h. So I have 2 times 2 plus h squared plus 1. So that's f of 2 plus h. So now that I know what f of 2 is and what f of 2 plus h is, I'm going to go ahead and substitute these back in to here. All right, so I've got the limit as h approaches 0. So f of 2 was, or f of 2 plus h was 2 times 2 plus h squared plus 1. And then minus f of 2 was 9 all over h. All right, so here's our f of 2 plus h. And here's our f of 2. We substituted those in. Now, we can't use direct substitution because I'll have 0 in the denominator, so we're going to have to do a little simplifying. So I have the limit as h approaches 0. So this is going to be 2 times 4 plus 4h plus h squared. That's what 2 plus h squared is. And then plus 1 minus 9, so that's minus 8 all over h. And let's distribute that 2. So I have the limit as h approaches 0 of 8 plus 8h plus 2h squared minus 8. All right, that minus 8 is over there, all over h. These 8's are going to cancel, positive 8 and negative 8. Okay, and then I can see each term that's left in the numerator has an h in common, so let's factor that out. So I have the limit as h approaches 0 of h times 8 plus 2h, factoring in h out of both of those terms, over h. And that works out because those cancel out. Now we can use direct substitution. So I'm going to have 8 plus 2 times 0, which is 8. So the value of this difference quotient as h approaches 0 is 8. All right, let's take a look at another example. This one's just a little bit more complicated. So now instead of the 2, I'm just leaving the h in there. Okay, so we're doing it more generic. Again, we can't just plug in 0 because we'll have 0 in the denominator. So my f of x, this is my f of x. So that's going to go in for that now. Instead of having a number that goes in, I'm going to actually plug in this whole function. So let's figure out what f of x plus h is. F of x plus h. So I'm going to plug in x plus h in here. So that's the square root of x plus h minus 2. Notice I took this x here and I put in x plus h, okay, because I'm substituting in x plus h. All right, that's usually a spot for confusion, so if you're having trouble with that, make sure you let me know. All right, now that I know what f of x plus h is, I can substitute that in here. So I have the limit as h approaches 0 of the square root of x plus h minus 2. We don't really need those parentheses. Minus f of x, so f of x is this function, so square root of x minus 2 all over h. And now we have to simplify, so let's use our conjugate technique here. So let's multiply by the square root of x plus h minus 2 plus the square root of x minus 2 all over that same thing. So the square root of x plus h minus 2 plus the square root of x minus 2. Again, the reason we use a conjugate is because when I do the inner and the outer, they're going to cancel. So all I have to worry about are the first terms. So this is going to be the limit as h approaches 0. We're going to have x plus h minus 2 from the first terms, and then minus x minus 2 from the last terms, all over h times the square root of x plus h minus 2 plus the square root of x minus 2. I know it looks messy, it's about to clean up. So if I combine like terms here, this x and that minus x are going to cancel, and this minus 2 and minus negative 2 is going to cancel with that. So really the only thing I'm left with in the numerator is an h. Let's bring along our limit. So I have the limit as h approaches 0 of h over h times the square root of x plus h minus 2 plus the square root of x minus 2. These h's will cancel out, and I'm left with a 1 in the numerator. And now I can substitute in 0. So I'm going to have 1 over the square root of x plus 0 minus 2 plus the square root of x minus 2. So this is just x minus 2, so I have square root of x minus 2 plus another square root of x minus 2, so that's 1 over 2 square root of x minus 2. Let's do a little rationalizing. We'll multiply by square root of x minus 2 over itself, and I get the square root of x minus 2 over 2 times x minus 2. These two multiply together, it's just x minus 2. And our final answer becomes x minus 2 over 2x minus 4. All right, so what this turns out to be, this is called a derivative. Okay, and we'll talk more about this later in the semester, but again, this is our first glimpses into calculus. For those of you that may know how to find certain derivatives already, make sure you know how to find a difference quotient, because that's what I'll be assessing you on. Again, if you have any questions or you need any clarification, make sure you let me know, and we'll see you next time.